Assalamualaikum and good day. My name is Mohd Amerudin bin Abdul Samad. Today, I would like to present my final year project. First of all, title for my project is Development of Chicken Egg Incubator based on solar panel with IoT system. My supervisor is Dr. Mohd Hafiz bin Abdul alias Amerudin. Okay, first of all, we'll go to the introduction. The farming, the factory farming is related to industrial raising of farm animal indoor under concept of extremely preserved mobility. For those who wanted to be an excellent farmer, a chicken eggs inverter is one the inverter that provide opportunity for the to success. In order to maintain their efficiency, performance, and operation, all inverter for quality chicken egg need to be have sustainable power supply. The egg will lose the hatching value if the power supply breaks down. Okay, we go to the problem segment. In this project, I have three problem segments. First is the egg hatching process. Second, the internal traits such as wild animal. Third, the existing incubator not environmentally friendly. The hypothesis for this project is there's a significant relationship between incubator temperature and egg condition. Second, there's a significant relationship between incubator humidity and egg condition. And this project is to hatching 10 of chicken egg using automatic incubator. Second, to develop automatic incubator based on solar panel. To monitor the egg incubator using IoT system. Uh, two. Now we go to the objectives of this project. In order to develop this project, the following objectives must be fulfilled. First, to develop the incubator with automatic controlling the humidity and temperature. Improper control means that the temperature or humidity is too high or too low for such a last of time that interfere with the normal growth of and development of the embryo. Second, to build incubator that using solar panel and be equipped with IoT system, making an egg incubator that use friendly will produce more valuable product and use green energy. The scope of this study are for the system will use microcontroller, not MCU. Second, the heat energy will provide by 20 watt bulb. Second, incubator temperature should be maintained between 38 degrees Celsius to 40 degrees Celsius. LM35 we will use as a temperature sensor. Okay, the fan will turn on if incubator temperature more than 40 degrees Celsius. The incubator designed for hatching 10 of chicken egg. Okay, lastly, IoT system will monitoring the temperature and humidity of the incubator. Now we go to the chapter 2 is literature review. First is incubation basic. Incubation basic is process of providing specific ambient condition for a period provide of hatching of egg. Turning egg when the incubator is better, it has been provided more turning equal better hatching. This can be carried out automatically, but a minimum of 3 times a daily required for turning by hand. The candling is the technique of observing the egg development through the cell. It's a simple method of shining a bright light through a hole in front of which an egg is placed. Now we go to the embryonic development. Embryonic is the process we can know the growth of the embryo development of the chicken. You can see the picture here from day 1 until day 21. You can see how the egg is being grown up. That is a egg incubator. The success of this type project depends on proper care and incubation of the hatching egg so help raise chicken are produced. The size and type of incubator depend on the need and future plan for each producer. Many different models are available. For continuous sitting, separate incubator and hatching unit are recommended. If all chicken in the unit are at the same stage of incubator, a single unit can be used. Locate the incubator and hatching unit indoors to protect them from major weather change. It is essential that the room has a good ventilation system to supply plenty of fresh air. Keep the unit indoors, make it easy to maintain incubator temperature and humidity. There are basic two types of incubator above. First is forced air and still air incubator. Forced air have a fan that provides internal air circulation. The capacity of the unit may be held large. Now we go to the incubating condition. So many types, this has some not has the same condition incubating condition. You can see here there are species that have incubating period and the temperature and humidity is actually not same for the other species. You can see here chicken have incubating period is 21 days. Now we go to the solar energy. Here we can see the solar panel connection diagram. For the solar panel, we can see is the solar panel will be used to charge the battery here, and battery will connect to inverter so that from DC it will convert to AC. After we DC, so any load that use AC can be used. Now IUC system. IUC system is nowadays we familiar with the IoT system. Okay, this is the IoT system architecture. Now we go to the methodology. You can see this project development. First, we start project review, and this we have three major components. First is mechanical design, electronic design, and software design. From the figure, they show the system of incubator working. First, user need to turn on the incubator supply. That is for system provision from the other division and make the system functioning constantly. For this project development, chicken egg was selected to be placed in the incubator. The condition of eggs have been explained in table 1.1. In order to give the good hatching an egg, the egg should position 2 or 3 times per day. The important to make sure all position of egg hit by length. Humidity of the incubator was controlled by water pump to give some fresh air flow and fan controller to make the surface humidity in incubator. You can see this incubator casing. This is a drawing of incubator box for my project. Now we go to the hardware design, and the hardware design is have two sections. One is the input and another is output. In the input we can go, the input is power supply, humidity sensor and temperature, and output is lamp, fan, water pump and LCD. This is the second diagram for chicken egg incubator. You can see this is a microcontroller, not MCU. This microcontroller is the brain of the system. This will control all the activity in the incubator. LCD will display temperature value and humidity in the incubator. So fan will be used to control the temperature in the incubator. If the temperature more than 40 degrees Celsius, the fan will turn on. This is a 20-volt light bulb. This bulb will be used as a heat energy to the incubator. This will be they will hit the eggs in the incubator. Water pump. Okay, water pump in this project will use to control the humidity in the egg incubator. So this is a LM25, the temperature sensor used in this project. This is DHT22 is the humidity sensor. Okay, now we go to the software design. This is a logo of software, Arduino software logo. You can see this is the coding for the LCD to display the value of temperature and humidity. Now we go to the sensor program. This is the coding for the temperature. We can see this here is a temperature. Now we go to the humidity sensor program. This is coding for the humidity sensor. Okay, now we go to Blink software. Blink software is used to display the value of humidity and temperature using a smartphone. All the data that carried out from the incubator will transfer to the Blink software, so we can monitor the egg incubator condition using the smartphone. This is the coding for the Blink software. Now we go to the chapter 4, which is the result and discussion. You can see here, this is the prototype of the chicken egg incubator based on solar panel. You can see here they have a solar panel here. Here we can see the data we got for 21 days. This is data is incubated temperature based on off controller. You can see here this data you get from 24 hours and we did in 21 days. After we get the all data, we will find the mean for the each day 1 until 21 day. After we get the mean for the 1 day, we will find the mean value of temperature during incubator period. We can see here the value temperature during incubator period is 38.9 degrees Celsius. Now is the data that collect humidity data that we collect during the incubating period. We can see here, same as the temperature, we collect the data on day 1 until 21 day. After we get data, we will find the mean from day 1 until day 21 day. After we got the mean value for the humidity, we can find the mean value of humidity during incubator period. So in this data we get the 33.2 humidity value during the incubator period. So the conclusion for this project, at the end of the project, all objectives for the study has been completed by using hardware and software. Such as this study has been able to successfully develop an incubator that can accommodate about 10 eggs at a time and operate automatically. The aim and objective of the project have been achieved. An accumulating egg incubator and hatchery has been developed and it could be used to incubate chicken egg. Thus, having result for day of testing, an average value of temperature was given to be 38.9 degrees Celsius. Average percentage humidity value is 33.2%. Besides, temperature was measured using LM35LC and its value displayed on the LCD. In addition, this egg incubator successfully operates using solar energy and can be monitored using IoT system. Okay, now we go to recommended for the future work. First, I recommended to design the incubator system using for PID controller, so the system performance is getting better. Second, uh, including of step motor for better angular movement of egg tray. Second, design the incubator that can be used variety of type of chicken. So there's many type of egg can use the incubator. Lastly, inclusion of an inverter as a backup power supply for this incubator. So we have not will power supply breakdown will can be overcome. Okay, that's all for me. Thank you for watching. Goodbye and assalamu alaikum.
Assalamualaikum and good day. Today I will demonstrate my final year project. First of all, this is my prototype for chicken egg incubator based on solar panel. Okay, we can see here, this is the solar panel. Okay, this solar panel will connect to the solar charger controller in this. So this device will charge the battery. You can see here battery, 20-volt battery. Okay, this battery will connect to the inverter. Okay, this inverter will function as it will change the DC supply to AC. You can see here AC. So it's a connection. Okay, this is our prototype of the incubator. Okay, now we will go to the inside the incubator. Okay, when you see they have two drawer. First drawer is where is the egg will place. You can see there. Now this is the 20-volt bulb used to be hit the egg. Okay, you can see if the temperature more than 40 degrees Celsius, you can see back there they have a fan. Fan will turn on if the temperature more than 40 degrees Celsius. We can see here this is a second bulb. Let me see this second bulb. It will turn on if the temperature inside the incubator less than 38 degrees Celsius. Now we will go to the second drawer. You can see here this is the microcontroller, not MCU. You can see is the LCD now display the humidity level and temperature inside the incubator. Okay, this is a water pump. Water pump will turn on if the humidity inside this incubator less than 35%. You can see here, you can see they have two container that contain the water. Okay, if temperature inside the humidity is low, so the pump will turn on and the water inside the incubator, this is the container that will store in the incubator, will fill up the water pump will fill up this container with the water. This from this, and will pump from this container, will pump into this container. This is a function of the water pump. That's here the not MCU. And now we will go to the IoT system, where we can see here this from the smartphone. We can see the value of humidity and temperature. IoT system will show the IoT system will make the user can monitor the humidity and temperature level inside the incubator using a smartphone. You can see here this is a value, humidity and temperature. You can see it is same as this display at the microcontroller. Okay, we can use the smartphone to monitor the humidity and temperature. Okay, this is all from me. Thank you.